we started a new programming language, what does it do, and basically how it can help you in certain use cases. So specifically, we are concentrating on doing network distributed applications, and we'll see how Ballerina is tackling that problem. So my talk consists of, I'll go through some slides. Also, I'll be doing some demos, some live coding to show some of the features of Ballerina. So yeah, let's start with a bit of going back in history. So we have seen that with time, we have increasingly created complicated, complex software due to user demand. So, and how we are creating this complex software is by basically continuously disaggregating our architectures. That means we are more and more componentizing our software systems and designing the systems as such. And these components, with time, they moved around and they became network accessible. That means they crossed the network borders and they became exposed through services. So when your applications are implemented, you have to talk to these endpoints to get the full application capability. And so with communicating with these endpoints and creating these compositions, we come into the problem of integrating with these endpoints. That means you have to do resilient communication, you have to discover endpoints, and so on. So it provides some unique challenges. So as you can see here, you have to do like transactions, circuit breaking, handling different protocols, and so on. So we need to have a mechanism to handle this efficiently. So we have been creating products in doing this as middleware. So the approach we followed there was like creating DSLs, domain-specific languages, mostly config-driven, in doing these connections or defining the integrations. So this works well for some class of integration problems, but especially when it becomes more complicated, your systems become very complicated and the integration logic is complex, the scalability becomes unmanageable. So basically, mainly, these configurations are not that agile, so it's hard to express your needs. So then we saw that people are moving more towards a code-first approach. That means they do the integration aspect also in code. So, and also we saw that more and more network applications mean their application logic itself is just an integration with other services. That means mostly their operations are done by communicating with external services. So the integration aspect itself became the code. So, so then we were looking at, OK, how do we improve this experience? So we had to make that experience of doing the integration with code more productive. So that's where we came with Ballerina. So Ballerina is an agile, network-aware programming language. So what we have done here is we have created some abstractions for network operations for the language to be network-aware. For example, Ballerina understands like services and network endpoints, resiliency, and so on. and transactions between these endpoints, and so on. So these have been brought in as first-class concepts into the language. So you may be thinking like, okay, I can do the same thing with other general-purpose languages by using a library, or like probably using a bolt-on framework, and so on. But the point is, still, it's then considered second-class functionality, and the developers most probably have to spend like some time with the boilerplate code to get that to work, and also that means more debugging, more error-prone to get things wrong in that layer, and so on. So we want to make the network operation side as productive as possible. So the best way to show this is I'll directly go into a small hello world sort of program with Ballerina, and from there I'll build up the features on how we actually do this using the language. So I'll be just doing a simple REST service, where I will do a GET request, and you will respond with a fixed message. So I'm using VS Code here. So Ballerina has a VS Code plugin. So the basic structure is, as you can see, we start with a service, and a service can have multiple resources, which will represent a specific context in the service. And I'm simply going to respond with a message. So that is it for our Hello World service. So let's just name these. You can just run that. So the default root context would be the service name, and then the context of the resource would be, again, the resource name by default. You can override these values. So you got the response. So that's simply how we would write a hello world kind of service in Ballerina. So next part is these services and the behavior can be customized during annotations. So for example, like in that service, I basically get all type of requests, HTTP GET, POST, anything is coming inside. If I want to limit the type of request coming in, I can mention that, and also probably customize the context I have. So that is done with the service level annotations. So I can just say methods, post, and oh, sorry, that should come to the likewise. So now I can't do get anymore. That should fail. Yeah. So now I have to do also the context should be this. Method is not allowed. So yeah. So you see that I can quickly change the behavior of the service using these annotations. So then the other way of customizing the behavior of your program is then to use connectors. So that's the other main function of the language, where the network connectors, the language is aware of network interactions especially. So we have normal function calls where you do as in other typical languages. Also, we have something called actions. Actions are executed against a network endpoint or client. So one of these network connectors will have a specific set of actions. So then the language actually knows you are going to do a network operation, so it will do any needed optimizations and so on based on that. Like, for example, Ballerina has out-of-the-box observability features. So these observability aspects are done since it explicitly knows that you are doing like services, network actions, and so on. So I'll quickly show the usage of a connector here. Quick check. Okay. I'll simply use the same source file earlier. It's easier. Okay. For this one, I'll So I'll go through the demo here. So what I have done is basically imported a connector called Amazon Recognition Connector. So basically, it interfaces with the Amazon service here. And I'm just simply creating a configuration object and passing some configuration parameters. And this is the network, like the client I mentioned earlier. It represents the network endpoint I'll be using. And in the actual service, I'll be calling its detect text action. So that's a special operation we are doing with the client. And when I get the result, I'll simply be responding back with the result to the user. So let's see, let's run this and see how this works. So we are running this locally. And so the data I'm sending is this binary image file that's here. So now the binary data will be sent to the Barna service, which will be forwarded to the external service, and you get the response back. So it's basically an OCR operation that is being done through the service, and the rest, you're getting the response back. And also another core feature of the language is ID is some problem with my ID. Let me quickly restart it. Okay. So when you write Barna code, so the language is designed with a sequence diagram model. That is, all the language constructs are compatible with for creating a sequence diagram out of the code. That means anything you basically write in code will be visualized automatically here in your diagram. For example, so it'll be updated immediately. So likewise, so it works both ways. So you can go and edit the diagram also and do the operations here, which will be shown in the code as well. So what it entails is basically it's self-documented code at the end of your Barna programs. So that is for the sample application. So another main operation, set of operations we support is when we said network distributed operation support. We also support deploying Barna programs in containerized environments and in Docker, basically in Docker and Kubernetes. So this is done using a compile extension mechanism, where it's not only restricted to only Docker and Kubernetes. You can do like AWS Lambda, STO, and any of your custom deployments as well. So I'll quickly show how the Docker, the Kubernetes functionality can be added. So it's just a matter of adding a few annotations to the service. Basically says how to expose your service and so on. So then after you build it, it automatically generates your Docker container and the Kubernetes artifacts automatically. So then it's just a matter of running this a single kubectl command, and it will be deployed to your Kubernetes cluster. So you don't have to write your own YAML files and so on. So you can see here it's already deployed. Have your service here. So let's try to invoke it. So you see, we got the same response as well. So now it just went through Kubernetes without going through the local node. So in the same way, as I said, we have AWS Lambda support as well, where we have deployed a custom Lambda layer to AWS. So you can simply write a Ballerina function, and it can be exposed through AWS Lambda. And as I said, observability is another main part of the system. So this is supported out of the box from the language. Basically, by switching on a global property, you can have observability features for metrics, distributed tracing, and so on, sending events to your monitoring servers without doing any custom code to do so. So some views of that happening. So you can see, so we basically interface with open tracing. So you can do servers like Jaeger, Zipkin to do the distributed tracing parts of your services. So all of this without doing any custom code in your Ballerina programs. And also the metrics parts are done by with Prometheus and Grafana for visualization. So again, all the default ones, so since of the network awareness of the language, it'll automatically do the default instrumentation needed to get these stats out. And yeah, of course, logging also, so we can directly integrate with logging systems like ELK. We have some templates that you can use to configure these agents and get the dashboards in. Also, another important part of writing your services is giving the definitions out to the consumers. That means the contract, the schemas, and so on. So we support the Open API standard, so which is Swagger earlier. So using the Ballerina commands, you can, for example, generate the Open API definitions out of our services and create skeletons, stubs, and so on with the Ballerina command. So if I quickly show our service, I can just say, Open API export. So that yes, that basically generated the Open API definitions from that service we gave there. And the other important fact, so as I showed you earlier, the language is based on a sequence diagrammatic model. So anything you write is visualized as a sequence diagram model. So the idea is when you're writing complex software, you start with a sequence diagram, mostly modeling your systems, parallel operations running on your service, and so on. So as you saw, like remote endpoints, databases, and so on are all visualized actors here, and you do basically actions against those. So basically, this is a high-level view of the ecosystem we have in Ballerina in achieving our goal of doing efficient like network distributed operations using language. And of course, we are constantly adding more to the ecosystem for wider usage. So Ballerina, the implementation is fully open source, the compiler, the runtimes. So you can join the discussions here in like Slack and Stack Overflow. You can go and check out the code in GitHub. And the website is ballerina.io. It has a wide range of examples and guides to get you started up quickly. That's it for my presentation. I can take any questions if there are any. Yep.
Hang on a second. I've got a mic, and we can so that way we can get the questions recorded. Who is asking? Can you show your? Oh, right there. Okay, thank you. That way everybody watching the live stream can hear you. Here you go.
I have two questions about your documentation.
Yeah.
You didn't use any comments. Are there comments in Ballerina?
Yes. Yeah, you do have comments. So in the normal, you can use the double slash to do comments. So those are already available. So yeah, I did use it in the sample. Yeah.
Okay. I've seen systems in the past which connected back to the language, and if you took the diagram that the language generated, modifying the diagram actually generated code.
Yeah.
Do you have that capability?
Yes. Yeah. So in the diagram, you can go to an edit mode. Okay. Today my
Thank you very much.
ID is acting funny. Okay. It takes a bit of time. So using this edit mode, you can go and add your constructs like this. So you can get the constructs and edit them, go to the code. You can do anything. It works both ways, basically. So yeah.
Yeah. So is this a compiled language or interpreted language?
It is a compiled language. So the current one, the already released one has our own bytecode format. So it's executed on a VM that is again running on the JVM. But from the next release onwards, we are directly compiling this into a JVM bytecode. So it will directly run in the JVM without any other runtime. Also, we are again planning, working on another runtime, a native runtime, which will just simply compile down into native code as well.
Can I use this side by side to Java? Let's say, for example, if I want to write my resources using Ballerina and I want to write my application still using Java or Python, is it possible to import the classes and interfaces that you've written here as a bytecode?
Yes. Yes, especially, so even now you can. So we have an external function mechanism. But in the next release, we have made it a bit more easier also, where you can import Java packages and use them inside Ballerina code as well. So you can do that, yes.
I see that you are using some libraries like Kubernetes and other libraries.
Yeah.
Are they embedded into the compiler?
Yeah, the Kubernetes one and the AWS Lambda and a few selected ones are shipped with the compiler. There are some optional ones that are outside. So these ones are there already when you download the compiler and use it. Yes.
Okay. Thank you.
Yeah.
Thank you. Other questions? You can see the curtain is magically open to the show floor, which is open, but we still have time if there's another question. If you want to talk to him privately, please feel free to do so. Please feel free to go to our floor. and we will reconvene here at 12:50 for a panel on DevOps. Thank you very much.
Thank you.